We developed the biogas package to make it easier to work with biogas data. The first step in using it is to install it, and it is available on CRAN, so it can be installed using the install.packages function. I won't submit this here because it's already installed. Then it needs to be loaded after it's installed. You can get a list of the functions and example datasets in the package with the help function. Here we go. And here at the bottom is a list of the functions and example datasets. And I'll talk about the low-level functions today. calcCOD, interp, mass-deval, mole-mass, predbg, and std-vol for a standardized volume. You can also find info on the package online. If you just search for CRAN biogas, it should be one of the first hits. Here it is, and for example, you can download a reference manual. It's just a compilation of all the help files for each object in the package, the example datasets, and the functions. So let's take a look at some of these functions. Simple function that is quite useful is std-vol, or standard vol. And it can be used to normalize, or rather standardize, a measured volume to some standard conditions. So say that we measured 100 milliliters of biogas saturated with water at 35 degrees Celsius. So that volume is equivalent to about 84 milliliters at 0 degrees Celsius and 1 atmospheric pressure when there's no water, so when it's under dry conditions. Now it's possible to use other standard values, so you can set the standard temperature and the standard pressure, as well as the units for pressure and temperature. calcCOD can be used to calculate the oxygen demand for anything that can be written as a chemical formula. So let's take a look at glucose, C6H12O6. Has a calculated oxygen demand of 1.07, and it's not necessary to capitalize. So for example, the oxygen demand of methane is quite high on a gram of oxygen per gram methane basis. Mole mass, you might guess, it's used to calculate the molar mass of any compound. Methane, for example, and let's look at glucose. And there's glucose, 180 grams per mole. Interp is used to interpolate gas composition or cumulative production, or it could be used for interpolating anything. And internally it calls up the interpolation functions that are available in the base packages in R. So let's take a look at some example data. So the comp dataset that's included with the package has information on biogas composition, mole fraction of methane in biogas for 9 different reactors for several different times. So we'll just work with one. I'll call it D. It's just for one particular reactor. So if we wanted to interpolate to, let's say, 10 days, we could do it like this. Time that out is where we specify when, and the interpolated value is 0.707. It's also possible to use a POSIX object for this first argument, the time argument. The mass to vol function is for applying the gravimetric method for measuring biogas production. So that is determining biogas production based on the mass loss of a reactor. So for example, let's say we measured a mass loss of 0.26 grams, 260 milligrams from a reactor, and we know the methane content of the biogas that was produced was 0.65, that is 65% methane, 35% carbon dioxide. And the temperature of the biogas just before it left the reactor, it's used to calculate its moisture content, was 35. That's equivalent to a methane volume of 140 milliliters. So that much mass loss indicates that 140 milliliters of methane was lost from the reactor. We can see more details by changing the value argument to all. You can see the value argument here is methane by default. And it's also possible to standardize to different pressures or temperatures. The last function I'll describe here is predBG, and it can be used to calculate theoretical methane production based on a chemical formula or COD content. So for example, glucose has a theoretical BMP of 370 milliliters per gram. Realistically though, we know that some of the glucose that we might use in a laboratory reactor, some of that glucose is going to be used to build microbial biomass and not just for energy. It's the energy reactions in this case that give us methane as a waste product. So we can say Fs equals 0.1. That's 10% going to build biomass, and that'll reduce the predicted value. predBG can do a lot more. So we can specify COD, for example, instead. We can specify some degradability fraction from the substrate. Perhaps it's not all degradable. And if we also give a substrate concentration, a pH, and a temperature, the predBG function can calculate CO2 partitioning between biogas and solution, and so give us an estimate of biogas quality as well. All of these functions are vectorized. I'll give you an example with stand_vol. Let's say we want to standardize not 100 milliliters, but we have three values: 50 milliliters, 75, and 100. 35 degrees. So the volume input here was a length 3 vector, and the output is a length 3 vector. All of them are vectorized. They can carry out similar operations. Two functions that are available in the biogas package that I have not talked about are cumbg for calculating cumulative biogas production and rates of biogas production, and of course methane production as well, and sumbg, which is used for summarizing cumulative biogas production data. The most typical use of sumbg is probably for calculating BMP, or biochemical methane potential, from lab data. And those higher level functions are described in other videos also available on YouTube. For more info on the biogas package, take a look at the manual, or of course you can send us an email.